In the third section of chapter 4, we will focus on complements and conditional probability. Maybe we do not have enough time to talk about Bayes' formula, but if you are interested in this topic, you can see the example because it's an interesting example. Okay. First, we should talk about the multiplication rule to several trials. This time we will have a new kind of questions called at least one questions. And we also talk about the conditional probability. So first, let's check the probability of at least one. At least one. First, we should understand what the at least one means. It means one or more. It means one or more. And the complement of getting at least one actually means 0. Right? If at least one means one or more, so we can use this. Greater than or equals 1. So the complement of greater than or equal 1, which will be less than 1. So here, less than 1, we only have 0. That means no one. So there's a step-by-step procedure to show you how to get the answer of this kind of questions. First, let event A to be getting at least 1. First, we set at least 1 as event A. Then we can get the complement of event A bar, as getting none. Right? Because at the opposite of at least 1 is less than 1. So that will be none. Step 3. Find the probability of A does not happen. So probability of none. After that, you actually interested in the probability of at least 1, not the probability of 0. So you should use the complement rule. Use 1 minus the probability of 0 to get the probability of at least 1. So this is step by step show you how to do this kind of questions. So let's check this example. First, we have the 6%. This number tells you 6% of the damaged iPads were damaged by backpacks. So it's the probability, right? The probability of the damaged iPad damaged by backpack. So this time 20 iPads are selected. We want to select 20 iPads. And we want to find at least 1 were damaged in a backpack. And the second question is, so the answer from the first question tell us the probability. Then we will work on that probability. Is that probability high enough? We can reasonable sure getting at least 1 iPad damaged in a backpack. So first we should get the probability, then we can discuss the second question. So we follow the steps. Step 1. We set at least 1 out of 20 damaged in a backpack as event A. So event A will be at least 1. Then second step, remember, we should find the opposite complement of event A. What is A bar? It will be none of the iPads were damaged in a backpack. So, or 20 damaged in a way other than backpack. So none of the iPads were damaged in a backpack. That's the complement of event A. So we can think that's the probability of none, probability of 0. After that, we try to find this probability. So if 6%, how can we get this 0.94? Because we know 6% of the damaged iPad were damaged in a backpack, which means 94% of the damaged iPad were not damaged in a backpack or damaged in a way other than backpack. So this is how we get 0.94, right? Not in backpack. So the first one, not in backpack. Second one, not in backpack. And the third one, and so on. All of 20 iPads were not damaged in a backpack, or we would say damaged in a way other than backpack. So we find the probability by using the multiplication rule, because each selection is independent. So we just use the regular probability, 0.94. Okay, after we get the probability of PA bar, we are interested in the probability of PA, not PA bar. Remember, we are interested in the probability of at least 1. So the final step, we should use 1 minus this probability of event A bar to get the probability of at least 1. So finally, we get 71% probability if we pick 20 iPads, at least 1 is damaged in a backpack. So it's 71% sure at least 1 were damaged in a backpack. So we can go back to check the second question. Is that probability high enough to be sure getting at least 1? So we will say it's just 0.71. It's high, it's more than 50, but it's not high enough. If we want to reasonably sure, so at least 90%. So which means we should select more than 20. Then we can reasonably sure one of the iPad will be damaged in a backpack. So this one is not very high. It's not high enough to make sure at least 1. So next, we will talk about conditional probability again. The first time we see the conditional probability in the formula of multiplication rule, right? So we check this is the notation of conditional probability. It's still the probability of event A, but this time it has the condition. It's still about probability of event B, but this time this one has the constraint. It has the condition. A has already happened. So let's check the intuitive rule to get the conditional probability. Event A has happened. Then we calculating the probability event B happened. Event A has happened. Then we calculate the probability event B will happen. So event A happened and event B happened, but we should divide it by the probability of event A. Probability of event A, because event A happen is our condition. So the denominator is the condition. You can treat the first one as like this one. Intuitive rule like and B divided by the number of event A. If you compare these two approaches, you will find that the intuitive rule will be much easy to understand. But if you use the formula, you will find that this is just a transform of the multiplication rule. Let's check the example. So if one of the 555 tag subject is randomly selected, find the probability subject has a positive result, but given the condition, actually uses drugs. So this is event B with the condition uses drugs. Uses drugs. Okay, let's see the solution. We can just use the intuitive approach. First, we count how many subjects has positive result and uses drugs. So that's how many positive result and uses drugs. We go back to check. Uses drugs, positive result, so it's 45. Right? So then divided by the number of event A, uses drugs. So we go back to check. How many people uses drugs? We will find this 45 plus 5. Check the first row, uses drugs, right? That will be total 50. So 45 over 50, we will get 0.9. We use the intuitive rule to find it. We can use this A and B. How many subjects both uses drugs and positive result, and make sure the denominator is how many people uses drugs, because here uses drugs is our condition A. Of course, we can also use the formal approach. Then we will just use the formal approach, use the formula. So this is the formula. The probability of A and B uses drugs and the positive result. So probability here is not the number of subjects, so it's the probability. So it's 45 over 555. It's the probability. So probability of uses drugs and the positive result, or probability of true positive, divided by the probability uses drugs. So total we know 50 people uses drugs, 45 positive, 5 negative. Add them up together, 50 people uses drugs, 50 people over 555. That's the probability of people uses drugs. So we use this one to get the 0.9. This is called formal rule. But if you compare these two approaches, you will realize the previous one will be much easier and easier to understand. Yeah, easier to use. Then we check the second problem. We want to know uses drugs given positive result. We switch the order of B and A. This time, positive test result will be our condition, not uses drugs. Okay, so that's the difference between A and B. This time, the condition is positive result. So how can we do it? We can just use the intuitive rule to do this. B given A, but this time A is positive result. So first one is remain the same. We need to get both A and B. So it's just the same thing. It's 45. 45 uses drugs and get positive result, true positive, right? But this time we want to get the number of our condition, so it will be number of positive result. From the table, we can know how many people got positive result. Positive result will be this column, positive result. So it's 45 plus 25, we'll get 470, right? So 50 people for this row uses drugs and 70 people test result. So this time we use positive result as our condition. So here, the denominator, we should put 70 here. And we have 643 as our result. From part A, we get 0.9. Part B, we got 6.643. You realized probability B given A, if we change the A given B, change the order. Because previous one, we talk about positive result given uses drugs. This time is uses drugs given positive result. We get this conclusion. If we change the order BA to AB, they are not the same thing. They are not the same thing. So this is the solution of part B. So we will find the conclusion. If we change the order A, B, B, A, they are not the same thing. So if we think these two are the same thing, then we made a mistake. And we have the name of this kind of mistake. We call it confusion of the inverse. So if we treat there the same, then we made this mistake. Let's see an example of this mistake. If given, if we check this, D stands for it's dark outside, or then M is it's midnight. Okay, event D means it's dark outside. M stands for it is just 12 a.m. midnight. Okay, so let's check probability of it's dark outside given it's midnight is equal to 1. Because midnight is our condition. So we already know it is midnight. So the probability of outside is dark is equal to 1. We can pretty sure if it's midnight, then it's dark outside, right? We're pretty sure about that. But let's check if we change the condition. This time, the dark outside is our condition. So we already know it's dark outside. But it's hard to say the time. It can be any time, something like 11:30 p.m. It can be 1 a.m. So it's not exactly midnight. So the probability of it's just midnight 12 a.m. is almost 0. It can be any time, right? It can be 1 or any other. So the probability is very small to be exactly 12 a.m. You can see the big difference between these two cases. So for the Bayes formula, if you are interested, you can check the example. It's a very, very interesting example, but we will not talk about it in our class, and we will not have any questions or quiz in any questions in your quiz or exams. So that's all for this week too. And make sure you check the announcement for the homework. The homework will not be collected or graded, but I still highly suggest you should do the homework. If you have any questions, you can mark the question, and you can use the face-to-face section to ask your questions. Okay, if you do the homework, you will find the quiz will be easy to do. Okay.